And I still don't know. All right, so let's see if we can go through some of this stuff.
If you don't know, you can just make it up here.
Make it up as I go.
Yeah.
All right.
We'll still write everything down.
All right, so we talked about what happens if we increase throttle. We don't have time to go through a decrease, but if you understood that, we'll see you later.
See you later.
All right.
Bye, Christian.
Okay, so chambers, we know chamber A is impact, thank you. Chamber B, Venturi suction. D is unmetered, but regulate. Wow, you guys are really good. All right, and C is constant, metered, okay. Main parts of the pressure carb system. What are some of the main parts we have? We have, we'll just put this here try this. Main parts of a pressure carb. We have the throttle unit. And what is in there? All right, Steve's awake back there. I'll say there's three things. 1, 2, 3. I heard throttle valve. What else is in the throttle unit? Sometimes I call that a throttle body. It will be called that later on. Some other stuff.
Discharge nozzle?
Discharge nozzle. Throttle unit. Well, then I have to add 4. I don't know why that wasn't there. I heard Venturi. And what else?
Impact tubes.
Impact tubes. All right, so the job of the throttle unit is controls and measures the mass of airflow to the engine, except for the discharge nozzle. It has something else, which is probably why they didn't want to include that in there, but we did now. The regulator unit. What do you think the regulator unit is? Its job is to automatically regulate fuel pressure to metering elements in the fuel control unit. Maybe I can write that. Automatically regulates fuel pressure to the fuel control unit. What does that sound like? Contains. Chambers A, B, C, D, and I would say E. With the diaphragms and the poppet valve and all that stuff. So chambers, we use a poppet valve. Diaphragms.
And I guess also
Yep.
the fuel pump, I guess, should be part of it too.
Well,
If something would fail and the fuel pump would put more pressure into E.
I'm not going to disagree with you. I like what you're thinking, and that's correct. It's part of that system. So that makes your answer correct. I think the thought here was it's an assembly in a box. What's in this box section right here? But yes, otherwise you'd be right. Okay, so regulator unit, fuel control unit. And let's see. Receives the fuel under varying pressure And the varying pressure is because the poppet valve is sometimes a little more closed and sometimes a little more open. So as we already talked about, the pressure in D varies, right? And then from there it goes on to the fuel control unit. So the fuel control unit is receiving this pressure that is not constant, so it under varying pressure from the regulator unit and meters it out towards the discharge nozzle. So it receives fuel under varying pressure. From the regulator. And meters to the discharge nozzle. And what can we say it contains? Any guesses here? Ooh, that was really good. One or more metering jets. And again, this can get to be very complicated in there with rotating discs and all kinds of things. But we don't need to get quite that into depth here. One or more metering jets or
Mixture control.
metering valves, like the idle needle valve. And then I have a separate one for discharge nozzle.
What about the mixture control?
I didn't put it into a main subcategory.
Okay.
We'll call that.
Wouldn't that be part of the fuel control unit though? Because it.
Yeah, could be. Yeah. And the discharge nozzle, its job is to, well, inject fuel into the airstream. The airstream going into the carburetor. Don't get any crazy ideas about just blasting it into the airstream around the plane. Let's see. It is a form of a pressure relief valve. It usually has a shutoff spring. To give a positive and clean shutoff at idle cutoff. Idle cut off. So what that is, you kind of have to imagine this pressure relief valve. As the pressure starts to bleed off, you don't want it to just kind of slowly dribble out of this nozzle and the engine just kind of coughs and chokes its way to death. You want an absolute clean positive. Hey, it's losing pressure, so it shuts down automatically. So to do that, it's a little more complicated than just simply a little spring inside there that's regulating pressure at 6 psi. There's got to be more to it with the back spring and back pressure, and it gets a little complicated in there, but we don't have to get into that, thankfully. So just know that it's designed to shut off quickly.
Wouldn't that also make sure that the entire system is continually pressurized at a certain psi?
Yeah, it's helpful. All right. So the PS5, we talked about that. Let's see, we had our chambers. What is A?
Impact air.
B.
Entry section.
And fuel enters in at what?
D.
E. Nothing's changed. D is
Regulated but not metered.
Unmetered, I like that. I also liked regulated, but unmetered. And then C becomes metered. All right.
And regulated too, right?
Well, at that point, yes, it's definitely metered and regulated. All right, let's talk about, let's see, components. I'm losing my... Yeah, what the heck. We'll do this. We'll say 5. And we'll say PS5 components. All right, so we already talked about all the chambers. We just did that. And, wow, I'll do this so I keep track. Chambers. Hit A, B, C, D, and E. We just talked about what all those were. We talked about the operation. And I would just put the operation. And I could say, see the stuff we talked about a little bit ago, because we went through the whole thing. And some of the components. Mixture control. And do you remember how the mixture control worked on the PS5? I'm seeing some heads going up and down, like little doggies in the back window. And how does it work? I like that, equalizing or changing the pressure between E and B. So it allows air to bleed from, I'm going to say B to A. Reducing air metering force.
Why B to A?
I would say the other.
You want A to B?
Because
All right.
it's sucking.
Yeah. From A, pressure sucking over to B. Okay.
Why would you say B to A?
Why would I say B to A? Mostly because just the notes are there, and I didn't really stop to think about it because I was thinking that there's something down below it, so I just wrote what I saw. So, reducing air metering force. What else do I have here?
Kevin,
Actually, I did write A to B, so my bad. Yes.
and you want air to bleed from A to B when you are leaning
Yes.
the engine?
Yes. So you're equalizing A to B. I hate to use the word equalizing. You're lessening the pressure in A and you're lessening the pressure in B, which means air metering force is less. So it means the poppet valve is going to close a little bit, which means less fuel gets through. Less fuel gets through there. Less fuel gets through the rest of the carburetor. But the throttle valve is acting independently of that. So you have the throttle valve, you push the throttle all the way forward. Say, I want max throttle. I want the throttle valve all the way open. But then you start pulling the mixture back and saying, but wait a minute, I'm going to decrease my air metering force so I can decrease the fuel that's being sprayed up at the same time. So you're adjusting the mixture. Reducing air metering force at ICO. What does ICO stand for? Idle cutoff. The mixture needle is pulled all the way out, equalizing A and B, which equals 0 air metering force. If you have 0 air metering force, what's the poppet do? Almost.
Idle.
It would go to idle. You're right, except What else happens?
The spring that's compressed.
Don't forget that little plunger comes up and depresses or pulls back the idle metering spring. And ICO plunger depresses the idle spring and closes the poppet. So as we pull this back a little bit, we're going to get that bleed right through here. Pull it out all the way, and it opens this passage completely. So these two want to just equalize, just like that, which means we lose all air metering force, and the poppet comes all the way back to its idle position. Pull it out a little bit more, and this ramp pushes on this, which pushes this down, which pushes this up. When this pushes up, it pushes on this little part right here and makes this whole spring thing go that way and sucks this closed and locks that up right there. And when this is locked up and closed, how much fuel gets through?
0.
0. So that is our idle cutoff. So. Am I okay doing that right there? AMC stands for automatic mixture control. Sealed bellows can be placed in the line between what? A to B. Right. Bellows uses an what kind of needle? Inverse. I feel like you guys got this.
Kevin,
Yeah.
I wonder why maybe I can't imagine it correctly, but I feel like as the inverse needle, even though the base is out first and the base is larger than the rest of it,
Uh-huh.
but even as the needle comes out further, it still has that surface area inside the tube. So why would that no longer restrict the airflow?
Because when it gets to the base is very skinny, and so it opens up that passage.
But where does the rest of it go? If it stays in the
Oh, out of the way.
passage,
Out of the way. I'm trying to think if I could.
Not the surface area. There's a seat. It's the size of the orifice, not the surface area. Yeah, it's not just the tube. There's an actual seat in it.
I don't think this is the best photo I have of it here.
You can try to draw it.
I could pretend to draw it. You're just mocking.
You could draw it.
You're just mocking me now, aren't you? Just mocking my drawing skills. Daring me to do it.
Never mock drawing skills.
All right, so what do we have here? I don't even know if I can do it on this one and color it in. But it's coming through here.
Okay, I get it now.
Hey, all right. She's just, thank you for saying that. I'll pay you later. What was I going to say? I don't even know now. See, bellows use an inverse needle. Yep, wrote that. Well, I don't know what I was going to write.
Altitude.
As something. Oh, thank you. As, well, kind of run out of time here, so we'll just have to say I don't remember what I was going to write there. What happens if the bellows gets a hole in it?
Rich at altitude.
Run rich at altitude, just like it wasn't there. Let's see. We talked about idle system. And what gives us the idle fuel?
Spring.
Okay, spring. I'm gonna have to get really short now. I know spring. What about the spring? Well, just spring. Spring. I just can't. And we also know, even though I'm not going to write this, that we have the little step needle that I never knew my real needle. We have the little step needle in there. And that also regulates fuel. F, acceleration system. And what kind of acceleration system did this have on here?
Accelerator pump.
Not accelerator pump. We're close. If you get stuck, you can read the board. It's okay. Diaphragm type. You guys are right. Yay, way to go. So that diaphragm type, so you remember low pressure on one side overcame the spring pressure. It pulled it back. It cocked it. It loaded it with fuel. And then when you lose, is it Venturi pressure? Manifold pressure. If you lose manifold pressure, then the spring pushes forward and it sprays that fuel out.
Doesn't have its own tube though, like on the flow carbs or anything. It just introduces it into.
You know, it
the
looked
flow,
like
right?
one picture showed that one style of carburetor did have an extra little jet on the side, and then another carburetor made it look like it added it to chamber C, basically, but later on in chamber C. Power enrichment. Talked about two types of power enrichment tonight. You remember those two types? Anybody?
Airflow.
Oh, right. Okay, airflow. And how did that actually enrich it?
Throttle it
pressure.
and open the poppet valve or pull the needle off the seat.
Pulled a needle off a seat, and so that provided bypass or parallel path. So it gave it a parallel path for more fuel. More fuel. And what was the other type? Ooh, I think I heard it. This is the long version. Manually controlled power enrichment. Which was the needle type. That used what they called a double step idle valve needle. So put that here. And one more thing. We have the vapor vent system, which is really just a little orifice that sent fuel and vapors back to the what? Tank. Excellent.
So as long as no air is in that chamber E, it constantly sends back a little bit of fuel.
Yep, constantly.
Never thought about it. I thought it actually had a little spring.
The PR-58 had the little float.
Right.
That's why I say, what happens if the float sinks? It just sends back more fuel. No big deal. All right. Afraid somebody's going to say that. I know. That was my fault. All right. In the interest of time, I will just tell you this. I'm sure it's in the book somewhere. So, pressure carb designators. So it's like there's the PS and the PR-58. The P is a pressure, it means pressure operated. The S is a single barrel, and a barrel is like the throat where the butterfly valve is. D is downdraft. H is horizontal. I don't have R down here, but what do you think R is?
Reverse.
What's that?
Reverse.
No, that's a good guess though. Rectangular. So it has big rectangular. The butterfly valves are actually big rectangles. So rectangular. Let me see. The dash number is bore size in increments of 1/4 inch. So a dash starting with 1. So the PS5 is a 2 inch. I didn't even write down what the 58 is, but the thing's huge. Yeah. So dash 1 is 1 inch, a 2 is 1 1/4, a 3 is 1 1/2, a 4 is 1.75. Follow? 5 is a 2. Although with the Bendix, I don't know, something I was reading said the dash 10, 3.25 is the largest, but that's got to be for like the PS or something.
You said to ask later a while back.
What?
You said to ask later a while back, but what is the purpose of multiple barrels?
The what? The
Multiple barrels?
more air.
Just more air?
More air, yeah.
Is the Venturi just not as strong when it's bigger?
You know, that's my take on it. If you get a Venturi that's this big around, it's, how that's not going to work. I think they're more effective when small individual ones. All right, I've got some stuff about starting a pressure carb, which I really talked about already. Let's see. One book talked about starting the pressure carb in the idle cutoff position.
I think that might have been a Q&A as well.
Yeah.
Okay, maybe that's why I wrote it. Start engines. I don't necessarily agree with that. In the idle cutoff position, and then you start it on the primer. There's different ways to do it, but. And I have just a few minutes to talk about water injection. So I've really explained, maybe not well, but we did talk about water injection.
AMI system.
And let's see. Also called ADI for anti DETONAT injection. And I will put this here, theory. So max, we're just going to, generally speaking, max power takeoff mix is about, what's stoichiometric? 50 to 1. Where did we determine, according to our data, that most engines are running for max or peak power? Okay, is that a little bit richer, or a little bit leaner than stoichiometric?
A little bit richer.
A little bit richer. And the reason for that is because of incomplete scavenge of cylinders and what's going on in there. Okay, so we're at 12 to 1, but we know when we go to max power, what needs to happen to the mixture?
Needs to go rich.
Needs to go a little bit richer. Why?
For cooling and anti-detonation.
Okay, cooling, anti-detonation. So max power takeoff then becomes about 10 to 1. How am I doing for my peak power?
You're less.
I lost it, didn't I? So, all right, just about the time I need my max power, I got to lose it because I got to try and keep the engine from killing itself. So, extra fuel is used for cooling and anti-detonation. So the overly rich mixture robs power. Well, let's use nice words. Decreases power output. So this is not a good thing. But if we use ADI, ADI allows, so what we're going to do is we're going to bring it, instead of running rich, bring it back to 12 to 1 where we have our max power, but now we have a concern about what? Detonation and cooling, but we're just going to spray water in. Just get a water nozzle and spray this water right up in there along with the fuel. And the water going in there is going to evaporate and cool the cylinder. And it has the anti-detonation properties of the water in there will help it out. So that is what's going on there. Allows the fuel-air mix to be set at best power. The water acts to cool the engine. And increases fuel performance rating. The octane rating, so to speak. And the water is going to expand with the air in there. And so we get all that. We are going to, I'll give you some numbers here. Results in a takeoff. Oops. Take off power. It results in a takeoff power increase of 8 to 15%. It could be, or it kind of depends, but how about this? Example. So the R2800 is rated at 2,000 horsepower. A 15% increase is 300 horsepower. Yeah, I'd say that's a lot.
Yeah.
What does ADI consist of?
60% water and 40% methanol.
Water, alcohol, and water-soluble oil.
Yep.
Too slow for you. I think he's losing it. Let's see, what can we do here quickly? We've got our tank going to a quantity gauge. In the cockpit, there is a switch to turn it on. I do not see a switch. And a light in the cockpit. That's what I need to talk about.
On the R2800, is that light the war emergency power?
I don't know. There's a switch in the light in the cockpit. The switch is to turn it on. In some of them, the switch is in series with the manifold pressure. So to draw it out, you have the switch for the cockpit, you have another switch for the manifold. And a light. And so if the pilot says, I want ADI and closes the switch, but my manifold pressure is not really high, what happens? You got nothing. So pilot closes the switch, has high manifold pressure, light comes on. Light indicates the system is on.
Would that be used with like a turbocharger or something? The map,
Well-
map,
Well, these radial engines, I mean, they had multi-speed superchargers already built into them
yeah.
with power recovery turbines and all kinds of stuff. All right, I think that's about all I have time for there. Let's see how well we did. All right, we talked about pumps and what's the primary pump in an aircraft? The engine-driven pump is our primary pump. How could I remember that? Because after takeoff, when we level out, turn off the boost pump. Don't need it running. And the boost pump is turned back on for landing and for emergencies, right? What do you do? Oh, you have a Continental system.
If I turn it on, it will kill the...
It's going to kill it. We'll talk about that. Yeah, his boost pump gives him problems. It's supposed to. So I remember that too. So boost pump can cause problems, especially in a Continental system. So the primary one is the engine-driven pump. What type of pump is the rotary vane pump?
Constant displacement.
Are you sure about that?
Mm-hmm.
Okay, me too. All right. What type of pump was the diaphragm pump?
Variable displacement.
All right. Man, you guys are on this. What type of pumps are most boost pumps, which are, by the way, not the primary pump?
Variable displacement.
Centrifugal. They're mostly centrifugal. Why would they choose centrifugal? Yep, extract air and the water from the fuel. Good one. All right, so we're flying along. Tyler, you have a what? Cherokee 180. So that's a low-wing airplane. And you carbureted, right? Even though he's got a carburetor, still needs a fuel pump. So he's got an engine-driven fuel pump. He's got a boost pump. He's flying along, and his engine-driven pump fails. The engine quits. He becomes a glider. What's he going to do?
Turn on boost pump.
Turn on the boost pump. But what if his engine-driven pump was locked up?
As a bypass.
Oh, man, got a bypass. All right, so he's going to be safe. Good thing, too. All right, but I'm picking on Tyler. On the front of his engine, or on his engine, he does have well, actually, you have a light coming, right?
Yeah.
So you're going to have the diaphragm pumps. But let's just say he's got a constant displacement pump, or I could say even that pump. I forget what I was going to ask. It's constant displacement pumps. He has a constant displacement pump, but his aircraft, because he's very, very cheap, and so he leans and gets best economy out of his airplane, and because he's a starving college student. So the pump is putting out all of this fuel, and it's got to go somewhere. What happens to the fuel that he's not using because he's economically minded?
It goes back to the inside.
Back to the inlet side of the pump. All right, I'll take that. What's a compensated fuel pump?
It compensates for the difference in altitude. the atmospheric pressure.
How does it do that?
It has a diaphragm that has a port either to manifold pressure or to the atmosphere.
Very good. Okay, so it varies the pressure on the diaphragm that either assists or hinders, thank you, the spring. The spring. Okay. In an aviation diaphragm fuel pump, how many diaphragms did we have?
3.
Ooh, okay. And let's think about the fittings on this thing. How many fittings could we attach to the diaphragm fuel pump?
3.
Ooh, I like 3. What are they?
Inlet,
Inlet, outlet, and the one that's got to be capped, right?
No.
Yes.
No, cap it. What if fuel's coming out of it?
It's supposed to.
Yeah,
No, it's not.
It's supposed
Then you
to.
have a leak in your diaphragm.
We have a leaky diaphragm, and we hope that that fuel is being plumbed overboard. All right. Could it? Oh yeah, inlet, outlet, and that little port.
It's just called that little port. That's the name of it.
The tattletale port. The drain fitting.
The new paint job.
What?
On the underside.
Drain fitting. Well, couldn't we just, if it started leaking, couldn't we just put some sort of T in the inlet and just run it right back in the inlet side of the pump?
Sure.
Try that.
Let me try. No, don't do that. How many check valves were there in that particular diaphragm? Okay. All right, now we got to think about pumps and how they work. If the size of the orifice is not changed and the pressure increases, what happens to the flow? Does it go up?
Yes.
Go down? Goes up. Okay. I should throw this question out. Maximum pump output pressure is with, according to the video, maximum pump output pressure is with.
A complete blockage. Right?
You're close. What did he say though? Zero flow. That's my guy right there. Zero flow. Everybody remember that? So maximum output pressure with the diaphragm pump was with zero flow. All right. Okay, so let's see. Well, you're going to have to know. You're going to have the test tomorrow. I'm going to give you the drawings of the 58 and the PS5. So you'll have those to look at. Let me see. Chamber A. So you have to know what chamber. So I'll say on a 58, what's chamber A, what's chamber B. So what's chamber A? B. C. D.
Regulated but unmetered.
And E. Nope.
Inlet pressure, fuel pressure.
I heard that. What was E? Okay, fuel pressure. It's not inlet fuel pressure.
Pump pressure.
It's pump output pressure. So it's fuel pump outlet. E, yes. And what's typical inlet fuel pressure from the fuel pump?
9 to 14.
If the air metering force exceeds the fuel metering force, what happens?
The pump opens.
Okay. How does a pressure carburetor sense airflow?
Impact near the venturi pressure.
I like that answer with both venturi and impact pressure. Well, talked about what happens at idle. So I've got a nice question here about I'm going to configure the carburetor in a certain way, and you need to tell me how much fuel is flowing or not flowing. What happens on a PR58 if the vapor vent should stick closed?
It's gonna run lean until
Burp is a technical term, yes.
the engine will run until the bubble has passed through the discharge nozzle, then it would run normally.
So it ran rich or lean?
Lean.
Is it going to run lean at all power settings or just intermittently?
It's gonna run lean momentarily until the bubbles pass.
Okay, so I would call that intermittently. All right, got a nice one here about the automatic mixture control. What happens if you're at a certain feet and the impact tube becomes clogged and you don't do anything, and what happens? What activates the economizer in the PR58?
Venturi section,
No, this.
right?
What did I ask you?
Activates the.
What activates the economizer?
Oh,
Increase pressure. Yeah,
When the pressure in
in
D, you're right.
is increased.
When the pressure in D overcomes
the string pressure and the pressure in C.
C plus spring pressure. All right. Let me see. How is the economizer activated on the PS5?
Venturi.
Two ways. By the needle as well as by air.
Okay. Let's see. Good. You know that one. Let's see. What happens if diaphragm between chambers A and B fail?
Idle.
You would be going back to idle.
Well, you're getting idle mixture at all RPMs or at all power settings.
So it would run. Okay. So how would it run at idle?
Fine.
What happens if I start to advance the throttle? It what?
Quickly.
It would run lean.
It'll run lean because the throttle's going to open and it's going to get more air and it's going to try, but it's not going to become lean at all power settings above idle. Automatic mixture control on the PR58 controls fuel A ratio by adjusting what?
What's too fast?
Impact air.
Impact air and A.
Okay, I like the impact air pressure.
Can you repeat that?
Nope. There was a question about how the mixture control works on a PR58. So as long as you know how that fully works, you'll be good. The float sinks in a PR58. If the float sinks, is it going to run rich, lean, or fine?
Fine.
Okay.
Oh, that flip.
What's the accelerator pump on the PS5?
It's diagram type.
Diagram time. Where is the discharge on the accelerating pump? Where does it inject its fuel? Into the main discharge nozzle or a separate nozzle? What activates the de-richment valve in the PR58? Put these closer together. What actuates the de-richment valve in the PR58? Ooh, ADI system. What's the purpose of the alcohol in the ADI? It's what?
Help it not freeze.
Oh, okay. Yes. She is correct. Prevent the water from freezing. Give the pilot something to drink.
And he gets blind afterwards.
What does the water pressure light on the ADI system tell you?
That system is
ADI system is working.
Activated.
On. All right. What time we got?
9:20.
Wow.